Welcome to the offline video on Prometheus and Grafana. We've already done a live video on this, but I'll be going from the top on all of these slides one by one. We'll understand number one, what is Prometheus? What do you use it for until here? Then we'll understand what is Grafana? What do you use Grafana for? And why are both of these the popular stack to do monitoring compared to New Relic? If you remember, in one of our offline videos last week, online videos, live videos, we understood about monitoring, logging, and New Relic. New Relic is a paid service. It's a very big company. Datadog is another such company that let you do monitoring out of the house. What do I mean by out of the house? I mean you go to their website newrelic.com or you go to datadog.com, and once you go here, you log in, you get some secret, and you start to integrate this into your application. This is how you do monitoring from a paid service. But what if you want to host all of this on your own systems? What if you want something like this, prom.100xdevs.com or grafana.100xdevs.com? What if you want to self-host monitoring? That is what we'll be learning today. How can you use two open source libraries to do monitoring in-house? The first one we'll focus on is Prometheus. Before we get there, let's quickly revise monitoring. What does monitoring mean? As the name suggests, it's graphs like these that you can look at, which tell you, okay, what is the CPU usage of my machine? How much storage of my machine am I using? What were the latest logs on my machine? What were the total number of error logs that appeared on my machine? As these counts go up, for example, let's say this specific graph goes up to 90%, you can alert yourself. You can message yourself, email yourself, okay, hey, 90% of the storage is full. You probably want to clean up your machine. That is what monitoring means. The name itself says monitoring. You are putting a monitor on top of your machines, on top of your processes, and making sure if there are too many errors, you send out an email. If the CPU usage is really high or the storage on the machine is almost full, you are sending out alerts. But what is the problem with a service like New Relic? It is paid, so you can't self-host it ever. They own your data. Your data exists in the database of the New Relic folks. So if they want, they can misuse it. No one does it, but if you want to really own your data, you will need to self-host. Self-host is a new term here. Basically means all of these monitoring dashboards, all of this data, which is effectively some data stored in a database. The CPU usage was 30% at this time and then 4% at this time, so on and so forth. All of this data is being stored on your own machines, on your own Postgres databases. That is what self-hosting means. That is what owning your data means. And it's very hard to move away from it. Once you have extremely complex dashboards here, you have written all the queries for it, it'll be very hard for you to move in-house, which is why it's usually a good idea to just start with the Prometheus and Grafana stack. That is what we'll be going through next. Firstly, let's understand the architecture of Prometheus. It has been written in a very ingenious and counterintuitive way. You would not think a monitoring system is built like this. So let's understand this architecture. Let's spend some time over here to understand how is Prometheus built under the hood. Prometheus is a time series database, and it can monitor your processes. For example, your Node.js process. If you have written node index.js, it can monitor it. It can tell you here what are the latest logs on this index.js file. Things like these. It can monitor your hosts. It can tell you here the CPU usage was this much, the storage was this much. So whatever New Relic can do, Prometheus can do as well. It can do a bunch of other things. It can also monitor databases. If you have a database, you want to monitor the number of reads that are happening, writes that are happening, CPU usage over there, you can do that as well. This is the general architecture of Prometheus plus Grafana. In the end, you have one instance of Prometheus running. You have a process. For example, if I'm here locally, I can run Prometheus, let's say you have one such process running, /Prometheus. You have a single Prometheus process running. That is the core of your application. That is the core of your monitoring. The job of this guy is to gather data from everywhere. What is happening on New Relic? It is gathering data from your host machine, from your Node.js process, right? The same thing needs to be done by this guy. So the first thing that is happening is you are running Prometheus and you have given it a bunch of targets. You have told it, okay, bro, you need to monitor this AWS machine. Let's say there is a AWS machine where you're currently hosting app.100xdevs.com. There is a AWS machine where all of this code is hosted. So you tell Prometheus, okay, this AWS machine, say you need to get all the stats. You need to get the CPU usage, storage, so on and so forth. You can tell Prometheus that there is a Node.js process running. From here also you need to get all the stats. You need to get the number of times a specific endpoint was hit, the number of times an exception was thrown, things like these. You need to grab from a Node.js process. And let's say there is a Golang process that is also running on the same Linux machine. Then you can tell Prometheus, okay, hey, please pull the metrics from the Golang process as well. What are metrics? Or at a global level for the Linux machine, the metrics are things like CPU usage, storage, things like these. At a process level, it can be any custom metric you want. It can be the number of times the /user endpoint was hit, the number of times an error was thrown. It really depends on you, okay, what you want to expose as metrics in your Node.js application or your Golang application. Let's look at a quick example of this. If you look at projects.100xdevs.com and app.100xdevs.com, both of these websites are hosted on the same Linux machine. If I SSH into that Linux machine, SSHing means I'm trying to connect to that Linux machine. Then over here, I can see the CPU usage like this. As you can see, it's hovering around 1%, 2%. So this specific pull that you see over here, Prometheus pulling my stats, it is pulling this CPU usage, let's say every 15 seconds. Okay, how much is the CPU usage right now? Achha, it is 5%. And then after 15 seconds, how much is the CPU usage right now? Achha, it is 6%. So it will every few seconds poll these stats. What else will it poll? It will poll how much space I have. As you can see, I have 15 GB available, used, 5 GB available, 20 GB total size, which means 75% of my machine is full. That is another stat that Prometheus can get from my machine. That is machine level stats. That is this arrow right here. And what are the other stats it can get? I have multiple processes running over here. As I said, if you look at the folder structure, it has chess over here. It has CMS. It has daily code. It has a bunch of my applications running on this server. I can pull the data from these applications as long as, of course, these applications expose that data. As long as I've written some code in, let's say, the chess repository or the CMS repository to expose some metrics, I can import those metrics into Prometheus. So what does Prometheus do? It pulls stats from everywhere. It pulls metrics from everywhere and stores them in a time series format. What does time series format mean? It means something like this. Our CPU usage was 30% at this time, 20% at this time, 5% at this time, so on and so forth. That is this part of the architecture. Notice Prometheus is a pull-based system. What does pull-based system means? It means that Prometheus in its own time, when it thinks that this is the right time for me to gather stats, will get the stats from the machine or from a process. These stats are never pushed to Prometheus. You don't tell the Node.js process, okay, here is the Prometheus server URL, push the stats here. No, you tell Prometheus, okay, this is the URL from where you can get the machine stats. This is the URL from which you can get the Node.js app stats, so on and so forth. A good example here is I have this small Node.js process running at prom.100xdevs.com. No, sorry, not prom.100xdevs.com. I have a small Node.js process running. Let's see. There you go. On week-25.100xdevs.com. On week-25.100xdevs.com, I have a simple Express application running. If I go to /user, you will see it gives me back some dummy user information. A simple Node.js application hosted where? Hosted again on this specific machine. In this folder right here, I have the code for it. If I go into this folder, you will see if I cat source/index.ts, it is a simple Express application which has a /user endpoint where I'm returning, a dummy user, let's say. This is the get user endpoint. It returns John Doe, age 25. That is exactly what comes over here. But this specific Node.js process, along with the normal things it exports, the /user endpoint, for example, also exports a metrics endpoint, /metrics. What does this log? What do you see over here? It says kr /user was hit 7 times when it returned a status code of 200. It is like a very big log of all my endpoints that have been hit. In fact, you can see, some people are trying to hack my systems. They're trying to send a request to /aws/credentials. They're sending a request to week25.100xdevs.com /aws/credentials. These are bots that keep on running from China most of the times that try to, attack your systems on some common vulnerabilities. A lot of times people have this exposed over the internet. That is why a bot hit this. There are a bunch of such dummy endpoints that were hit. For example, /config.xml /server.key. This was hit once. This was hit once. /robot.txt was hit thrice, so on and so forth. All of these I have in a single place on an endpoint called /metrics. And that endpoint is what Prometheus is polling. This part of Prometheus hitting my Node.js process and getting back the stats, the process over here that it's hitting, the endpoint that it's hitting is this. So what is happening? Every 5 minutes, let's say, Prometheus that I'm running somewhere is polling this. What does polling means? It is just hitting this and storing ki acha, the /user endpoint was hit 7 times until this timestamp. And then after 5 minutes when it hits, let's say this number goes up to 9. And then let's say after 20 minutes if it hits, this number goes up to 15. So that is how Prometheus gathers stats. It's a pull-based system. You can tell it to gather stats from multiple places. That is what this side of the graph means. But in Prometheus, if you really want, you can also push stats to Prometheus. A good example of this might be if you have a short-lived job. If you have a job that starts up, does something, and then eventually dies in let's say 20 seconds, then you can't wait for Prometheus to poll it. Prometheus polling interval might be 50 seconds. Once every 50 seconds, it gathers data from here, from here, from here. Since it is happening once every 50 seconds, the process might come up and die before Prometheus can ever poll it. And hence, if you have a short-lived job, you can push data to Prometheus. It isn't ideal. Ideally, you want Prometheus to poll data from various sources. You don't want any process pushing it. But if you have a short-lived job, Prometheus provides a way called the push gateway for you to be able to push stats to Prometheus as well. We won't be doing any of this. This is just good to know. Okay, even though Prometheus is a pull-based system, it pulls metrics from everywhere. You can also, if needed, push stats to it using the push gateway. Lastly, right now we had 3 hard-coded services: a Golang service, a Node.js process, and the machine level stats. Prometheus can also discover a bunch of pods in your Kubernetes cluster. Now we haven't done Kubernetes at all, so don't worry about this. But the whole point, my point here is, if you have an auto scaling group, if you have servers that are, starting and stopping really quickly, let's say this node comes up and then this node dies as well. And then another node comes up. You can use something called service discovery. So Prometheus can easily discover, this is node 1 and this is node 2 and start to pull stats from it. So it's not like you always need a hard coded URL. Okay, yaar, week25.100steps.com/metrics pe hi you will get the stats. No. If you have a bunch of servers that scale up, scale down, for example, we have covered auto scaling groups in AWS. If you have an auto scaling group where a server comes up and then goes down and then another server comes up, Prometheus can automatically discover these as well using something called service discovery. This also we won't be doing today. So, this part of the architecture you can totally ignore for today. The main part is Prometheus having a bunch of endpoints to poll, it polling them and storing all of their data in a time series format here. I repeat, Prometheus will be polling a bunch of processes. Polling means hitting them once every 15 seconds, once every 20 seconds, and storing here. KR, I hit the Node.js process on the /metrics endpoint and the /user route has been hit 7 times at this timestamp. And then it will hit it again. It will be like, it has been hit 8 times at this timestamp, so on and so forth. It will store the data here in a time series fashion. That is the general architecture of Prometheus. Once you have this very long database which stores, the user's endpoint was hit X times, something else was hit Y times, you can always query this time series data by using the Prometheus UI or something else. So this is the last part of this architecture. Okay, this is the database that's storing your data. You can always build a UI on top of it to query the data, to get back, to get back a graph that looks like this. Basically, if you ever want a graph that looks like this, you can query Prometheus and show the user a very nice UI. Let me show you some of these components deployed on the internet right now. This metrics endpoint you just saw over here. If I go to week25.100steps.com/metrics, you will see it is exposing a bunch of these endpoints. We'll eventually be seeing how you create it, but all of these stats are being exposed right now on this specific endpoint, that is this Node.js process right here. Prometheus is running on my server over here. If I do a docker ps, I think it is running using Docker. If I do a sudo docker ps, you will see this thing is running. I started it 4 days ago. Prom/Prometheus is the name of the image. And to this image, I've already told, okay, you are supposed to poll this Node.js process. So that is this Docker process running on my machine is Prometheus over here. And lastly, the Prometheus UI is also running on this machine and is currently hosted on prom.100xsteps.com. So if you go here to prom.100xsteps.com, this is a UI that I can, hit to get back, let's say the total number of HTTP requests that have happened in the last 2 days, 1 day, and show it in a graphical format. For example, if I click on /user, it'll show you the number of requests have been 9 for a while. I can increase the time duration here to, let's say 2 years or maybe slightly lesser, 1 week or 4 weeks. And then I can see the number of requests have been going up over time. That is what Prometheus UI, this part right here is. So what have we seen? This is hosted on prom.100xsteps.com. This is currently running in Docker on my machine. And this is a simple Node.js process that is also running here on my AWS machine. Let's understand how can you write, number one, a Node.js process. After you've written it, how can you start a Prometheus instance that is constantly polling it? And then we'll understand how can you create a UI and start to see some graphs on top of the data that the Node.js process is exporting. Let's get into adding raw metrics to your Node.js process. Let's understand this part. How can you create a Node.js process similar to mine, which has a page like this that can be polled by Prometheus. Right. Before we proceed, let's talk about the various types of metrics when it comes to Prometheus. Prometheus roughly lets you store 3 types of metrics. The first one is called a counter. The second one is called a gauge, and the third one is called a histogram. We'll be focusing on the first 2 right now. Eventually we'll reach histograms. But counters and gauges are actually fairly straightforward of things that you might want to track. What do you usually track in a Node.js process? You might track the number of requests. Okay, how many people are currently sending you a request? And this number will always go up. It will never go down. As time goes by, the number of requests on your system will keep on increasing. Another good example might be the number of exceptions on your server. The number of times an exception is thrown on your server is another metric that will only go up over time, right? You might have none for a while, but then one might come, then none for a while, then one might come, so on and so forth. It will never go down. This is what a counter is. Something that can only increase over time, but cannot decrease. Now, the rate of requests might go down. The rate of exceptions might go down. What do I mean by rate? I mean the number of requests change per second. Okay, initially there were a lot of requests, then there were lesser number of requests, and there were more number of requests. This might go up and down. The slope of this thing might go up and down. You might have extremely high slope first, then you might have very minimal slope, then you might have extremely high slope. So over time, you might be focused on the slope of these metrics. Yeah, I don't want to know the total number of requests. I want to know the number of requests per second, for example. Now requests per second can go up and down, but total number of requests will always go up. Hence, what do you use a counter for? You use a counter to store things like total number of requests. So Harkirat, what about the requests per second? What about this thing, the rate of requests? And the answer is this. You can always derive from this. If you have the total number of requests per second, you can always find the slope of it at various points to figure out the number of requests per second. So what do you usually store in your metrics table? You store counters. Are the number of requests per second have been going up like this. That is one metric that we are tracking. And let's say the number of exceptions that have come up over time since, let's say, you started this application 2 years ago, and then this is the current rate. This is the number of exceptions that have happened. This number is only going up over time. The second type is a gauge. And the difference between a counter and a gauge is, gauge is used to track something that can go both up as well as down. A good example is the number of the memory usage on your system, or the CPU usage on your system. This number can go up, it can go down. So if there is something that can both increase and decrease, you store it in a gauge. If there is something that can only go up, you store it in a counter. CPU usage is another example. You might have 3% usage, then you might have 80% usage, then it might go down to 2%, so on and so forth. Since this can go both up as well as down, you will store it in a gauge. If this could only go up, then you store it in a counter. Harkirat, why do I need counters then? I can only use gauge. Sure, you can only use gauge. You can even store the number of requests in a gauge, only you would never call the decrement function over there. You would never decrease it, you would only increase it. Gauge sort of covers the use case of counters as well. So that is what are the two popular types of metrics. If we go back to the slides, let me quickly open slides on my side. The types of metrics in Prometheus include a counter, a gauge, and a histogram. We'll be coming to this later on. But what is a counter? A counter is the cumulative metric that only increases. What does cumulative mean? It means you keep adding up the total number of requests as time goes by. If your application has been up for a year, you will have this number go up to 1 million, for example. Example, counting the number of HTTP requests. What is a gauge? A gauge is a metric that can go both up and down. It can be used to measure values that fluctuate, such as the current number of active users or the total memory usage that your server has. Example, measuring the CPU usage, memory usage, the storage on your machine. Let's look at just these two metrics. How do you track them? How do you expose them from your application? How does Prometheus pull them and store them? Eventually, we will reach histograms as well. Let's kick things off with counters. Now, we will have a simple Express application where, along with all of our other routes, we will also be exposing a new route for the metrics. If you remember, our week 25.100xsteps.com was exposing some standard endpoints. For example, the /user endpoint. This could be the /todos endpoint. It will expose these, but amongst all your user routes, it will expose one extra route, the /metrics route. Let's see how you can expose this and how this endpoint correctly calculates here the number of requests that have come to /metrics is this much. The number of requests that have come to the landing page is this much, so on and so forth. Firstly, you have to create a simple Express application. Let me do that really quickly. You will find the instructions to do this in slide number 3. You can also create, an Express application on your own by following these steps, or, just create a simple one yourself. I'm going to open this in Visual Studio Code. And now I'll start to initialize the project. npm init-y to create a package.json, npx tsc-init to create a tsconfig.json, change root dir to be /source, change out dir to be /dist, create a source folder inside which we have a index.ts file, add express and add types /express as dependencies, and then write your simple Express code. You can also copy it from the slides if need be. We have like a basic Express application over here. What does the application look like? We have imported Express as the library. Const app equal to Express is creating an instance of the Express HTTP server. App.use express.json. If you want to keep it simple, feel free to get rid of this endpoint as well as this, even though this is simple stuff if you've gone through Express until now. Let's stick to a very simple Express application. It has a single /user endpoint, which returns a hard-coded user to whoever is requesting. If I do a tsc-b to compile the code, and then node dist/index.js. If I try to go to localhost :3000, you will see /user. You will see I get back name John Doe, age 25. So I've created a simple HTTP server, which is not yet exposing any metrics. If I go to the /metrics endpoint, I see nothing over here. If I go back to the architecture, what does it say? Here you have to, your Node.js application, along with the other things it does, needs to expose a /metrics endpoint. And hence, with all the code that we've written here, we also have to write the code to expose a /metrics endpoint. Now this endpoint needs to follow a certain format. I can't simply do this. kr theek hai, app.get / metrics. I will just write whatever code I want. Rest.send metrics are this. No. The final set of metrics need to follow a certain format. If you go to week25.100xdevs.com/metrics, you will see it follows a certain format. Okay, this is the name of the metric, the total number of HTTP requests. This is the method that this specific route was hit with. The /metrics route was hit with the get request and got back a status code of 231,104 times. So this format is what I need to follow. And let's say I need to track the number of requests to the /user endpoint. How can I do this? Is there a library that I can use? Can I do this in-house? You can totally do this in-house. You can create your own, counter class or Prometheus class that tracks all of this. Or you can use a library like Prom Client. Now we're on to slide number 5. A library like Prom Client, which stands for Prometheus Client, that abstracts all of this from you. And you just give it a counter, it exposes it automatically on the /metrics endpoint. So we're going to use the Prom Client library. Should you? Yes. Can you do this yourself? You can, but don't do this yourself. Use the official Prometheus client that is available to you in Node.js, and use this to track all of your metrics. After doing an npm install prom client, what is the next thing we have to do? Harkirat, we need to track the total number of requests that come to the /user endpoint. I need something like this. Let counter equal to 0 and then counter ++. Anytime a request comes, I do counter ++. And whenever someone asks for metrics, I can do something like this. Okay, HTTP number of requests is counter. You want something like this, mota. Okay, if someone hits, let's try this out. What have I done? Defined a variable, initialized it to 0. Anytime a request comes to /user, I did a counter ++. And anytime a request comes to /metrics, I return in a certain format the total number of HTTP requests is this much. I have not written anything fancy like, method equal to get or other labels that you saw on the main website. If you go here, you'll see, we did not just have HTTP total requests equal to 31,000. We had HTTP total requests with these labels equal to 31,000. And hence, we are creating a simpler version right now, just a manual version that simply prints HTTP total requests is this much. If I go here and try to rerun the application, if I now try to go to localhost :3000 /metrics, you will see it says number of HTTP requests 0. If I go to the /user endpoint, let's say a few times, then if I go here, it says HTTP requests 9. So I was sort of able to create a counter, something that is going up as time goes by. If I hit this a few more times, this will go up to 12, so on and so forth, without using any external library. I have not used the Prom client over here. As you can see, I'm doing a very raw in-house approach without using any external library. You can totally do this, or you can use a counter from the prom-client library. The prom-client library exposes a counter variable, and rather than initializing an integer, you can initialize counter number of requests counter equal to new counter with, let's say, the name being HTTP requests total, something like this. It gives me an error. Help is missing. You also have to give some help text along. Okay, this counts the number of HTTP requests. Rather than doing let counter equal to 0, I have done this. Okay, you can also call it counter. Let counter equal to new counter with a capital C basically initializing an object of this counter class which comes from Prometheus client. Why are we doing all of these fancy things? Why could I not simply do let counter equal to 0? And the answer is because, creating this in-house as the number of metrics increases is going to be really difficult. And hence you should just use a library like this. Then, trying to figure out, acha, this is what I have to write or send back over here. You can just use a counter, and rather than doing a counter plus plus, you can do a counter dot increment over here. Here a request came to slash user endpoint, increase the counter by 1. Another request came, increase the counter by 1. Lastly, here on an app.get slash metrics, you don't have to do this. You don't have to figure out, acha, what is the current value of the counter. You can simply do this. You can import client, which is the default export of prom-client. And you can say, anytime a request comes to slash metrics, I will not create the metrics myself. I will not do, res.send total requests is some variable. I will not do this, or if you want to make it easier, I will not do this. This is something we were doing before. Now we can just tell the client library, KR, I created some metrics on you, right? I created a counter variable using the prom client library. I've been increasing it over time. Just tell me the current metrics. Client.register.metrics would return you all the metrics in textual format. You can simply send them back to the user by using rest.end. You don't have to figure this out yourself. You don't have to, maintain a counter variable which is an integer and then yahan pe figure out what the final structure of the slash metrics endpoint should look like. The Prometheus client library has already written the code to take all of your counters and convert it into the required format on the slash metrics endpoint. If I run this and try to go to localhost 3000 slash user a few times, then I go to slash metrics, you will see it looks very similar to how we had created a while back, but now it is tracking these metrics using the prom client library. I am not myself maintaining integers. The prom client library gives me a counter variable. I've been increasing that counter variable as time goes by. And anytime a request comes to slash metrics, again, the client library knows, the prom client library knows you had a counter that you had been increasing. You can just simply call client.register.metrics, get back all the metrics and return them to the user. This metrics variable that you see over here, if I log it and try to rerun this, you will see that metrics variable has all of your final metrics in the right format. This is the format that Prometheus understands. This is the endpoint that Prometheus would eventually be polling. If we go back a few slides, Prometheus would be polling our slash metrics endpoint. And this is the format it understands. Right now we have a very basic application, which is why, you have a very simple slash metrics endpoint. But of course, as time goes by and we'll be writing some more code, your metrics endpoint will become something like this. It will be, much more complex. It will have labels along with what is being tracked. Right now, we're just tracking the number of requests, but we might want to track how many requests happened with the get method on this specific route that returned the status code. You might want to get more granular. What does granular mean? It means you might want to add more detail. Total requests so is this plus this plus this plus this plus this. If you can keep adding them, you'll get the total number of requests. I also want individually how many get requests happen. I can add all the get requests over here. How many requests happen to the slash metrics endpoint? I can add all the HTTP requests that have come to the slash metrics endpoint. To recap, what have we done until now? We have created this simple application, literally a single index.ts file, where we say, Here, anytime a request comes to slash user, I am going to increment my counter, which I've defined over here. Where does this counter variable come from? It is an instance of the counter class that Prometheus client exposes. Anytime a user comes to the slash metrics endpoint, I calculate the metrics by again using a function that this prom client library exposes to me, client.register.metrics, and I return that to the user. That is how you create a very basic metrics endpoint. One thing that's missing here is dimensions. Prometheus lets you store more granular data. Right now we're just tracking the number of slash user requests. If I have another endpoint called slash to-dos, then I will have to create a separate counter for it called to counter, and then increment that, and then finally we'll have two different metrics over here: total number of user requests, total number of to-do requests. We don't want that. We want the variable name to be total number of requests, but we need to add more dimensions to it. We want it to look something like this. Here, the name of the metric is still this, but you can attach labels to them. Here, get request, metrics endpoint, status code, so on and so forth. Let's understand how can you add dimensions to the metrics that you are exposing. All right, this is what our code looks like right now. We have a single counter which we increment anytime a request comes to slash user, or even if a request comes to slash to-dos. What if I could do something like this? Label names route, which means we are going to add another dimension to our metrics. We will still have a single counter, but that counter will have various rows in the final endpoint based on the route that is being hit. For example, here I can be like route is slash user, increment by 1 for the slash user route, and here I can be like increment by 1 for the slash to-dos endpoint. If I now run this code again, you will see initially I have nothing. Let me go to the user endpoint a few times and the to-dos endpoint a few times. And now if I go here, I have two separate rows. One stating I hit the slash user endpoint 4 times. I hit the slash to-dos endpoint 4 times. I can still add them up and be like, yeah, the total number of HTTP requests is 8. But now I have more granularity. I have more detail. I can now check what were the number of requests to slash user, or what were the number of requests to slash to-dos. This is called adding dimensions to your metrics. You can make them more and more granular. For example, as I showed you in our final website, if you go to week25.100xdevs.com/metrics, we have not just the method, not just the route, but also the method that was hit with. Was it a get request? Was it a post request? We also have the status code that was finally returned. Was it a 200 status code? Was it a 404 status code? So on and so forth. Again, you can totally add all of these up to get the total number of requests. You can totally add all of these up where the method is get to get all of the get requests, so on and so forth. But adding more detail like this lets you finally query कि यार कितनी बार metrics hit हुआ था? How many times was the metrics endpoint hit? How many times was the server endpoint hit? And in our case, how many times was the slash user endpoint hit? And how many times was the slash to-dos endpoint hit? That is what dimensions let you do. Now we have a counter that we're incrementing with some dimensions based on which endpoint is being hit. But now the problem is, if I add a third endpoint, I will have to again, do a counter.inc the route over there. We don't have status codes in here, very similar to the production website that I showed you. So what if we could write an easier solution? What if I could write a middleware that does this? Rather than incrementing individually in the method body, can I write a middleware? Can I do something like this? App.use some request count middleware, And the goal of the request count middleware is to increment counter based on the current route. So I can do, let me TS ignore this because you'll see some errors. We'll eventually see how to fix them as well. I'm saying here I want to increase the counter for which route? Request.path. I don't have to individually go here and do your counter.inc for the /user endpoint and then again here. I am simply saying this middleware should be called for all of my routes. And what am I doing inside the middleware? I am increasing it for the current route. That way, I don't have to, even if I introduce a third endpoint now, /user2, this user2 endpoint also, before control reaches here, the control will go to the middleware. If you remember what middlewares are, if you do a quick refresher of middlewares, what does app.use a function name do? It basically makes the control reach here first, and only if next is called does the control reach the actual endpoint. Whenever the user is hitting the /user endpoint now, control will not directly reach here. It will first go to the request count middleware, this function, an increment would happen on the counter, and only then would next get called, and the control would actually reach here. If this feels jarring, then you haven't gone through middlewares well. So go back to week 3, week 4, where we have covered middlewares in a little more detail. Now I have 3 endpoints, and inside the body, I'm not doing any fancy counter.inc. The body is just doing its thing. I have created a middleware that is incrementing with the current route that the user has hit. Thankfully, the request object here gives us the current route that is being hit. And that is why if I now try to run this, let me restart it. And let me go to my browser and refresh. Initially, as you can see, it is tracking the number of times even the /metrics endpoint is being hit. As I go here, this count keeps going up. If I go to some /user endpoint or /user2 endpoint and hit it a few times, all of these will keep on getting added. And I don't have to individually write the counter.inc at the top of every route. I can simply create a middleware that does a counter.increment. If I refresh this, you will see metrics is being hit 25 times, user is being hit 1 time, user2 has been hit 8 times. If I go back here and refresh twice, you will see this becomes 10. That is how you add more dimensions in a more generic way. What do I mean by generic? Generic means I don't have to individually write this again and again. I have created a generic solution, a common solution for all of my endpoints. All of my endpoints will now have their individual counters incremented whenever that specific endpoint is hit without me having any logic over here to increase the counter. That is a more generic way to do counters. If you go to the slides, you will see here, so we have done something even better. In the slides, our middleware, firstly, in our slides, our labels are not just the route, but also the method and also the status code that is returned from the request. And in our middleware, we do a res.onFinish. Ignore the start time and the end time. This is just for logging how much time did the request take. So ignore this and this. In the middleware, I say res.onFinish, which means whenever this response finishes, whenever the user gets back a response, I increment the counter with not just the route. Don't worry about why this is so complicated. Feel free to replace this with route equal to rec.path. Don't worry about the ternary operator over here. So route is rec.path, method is rec.method, which could be a get, could be a post, and status code is res.statuscode. This way, I add 3 dimensions to my response. Let's try that out. Let's replace the dimensions we have here with not just the route, but also the method and the status code. And whenever we are doing counter.increment, before incrementing, let's wait for the response to finish because we won't have access to the status code until the response has finishes. What does the status code mean? It means that the request sent back a 200 status code. If I do a dot status 404, then the request will send back a 404 status code. But this request needs to finish for us to know that the current status code is this. Hence, we first wait for the request to finish. And once it finishes, let me remove all of this logic. We do a counter.increment with not just the path, but also with the method and the final status code. Notice the method comes from the request object. The path comes from the request object, but the status code comes from the response object. Because whenever you return back to the user, okay, this is your body and this is your status code, is when, you get access to it on the response object. The request user can never tell you this is the status code I want. You respond back with, acha, everything was fine. So there you go. There is a 200 status code. If there was an error, then you tell them, sorry, there was a 404 or let's say 511 status code. So this status code depends on the response object, which is why number one, we need to wait for the response to finish. Number two, status code we will grab not from the request object, but from the response object. If I rerun this now, go to Brave and then do metrics, you will see, I see nothing, but then I see here on the slash metrics route with the get method, with the response of 200, there have been 12 requests. If I go to /user/user2, if I refresh, it says here 511 wali on the /user endpoint, there have been 4 requests. I can go to the same endpoint and send a post request rather than sending a get request to /user. Let me send a post request to /user. Let me send it a few times. It returns an error because there is no handler for the post endpoint on /user, but you will still see it here now. You will see here the /user post request count is 4. The /user get request count is also 4. So total requests that have come to the /user endpoint is 4 plus 4 equal to 8. That is how you have multi-dimensional counters. You can still count the total number of requests. It's 14 plus 4 plus 4 plus 4. You can still count the total number of get requests. It's 14 plus 4 plus 4. You can count the number of post requests. You can count the number of requests that have returned a 511 status code, so on and so forth. That is how you have a more generic HTTP request pool. And now if I go to the production website, if you remember, what did the production website have? It is being hit by so many bots. It has by /about endpoint was hit once by a bot. /.vs code. I have not hit any of these endpoints. You guys haven't hit this specific endpoint. Some random bot is polling our server and trying to get, for example, the git history, trying to get config/production.json. It's trying its best to get back something. It won't because our backend isn't vulnerable, but you can clearly track. Okay, it's trying to get the laravel.env file. Laravel is a web framework in PHP. It's trying to get my SendGrid environment variables. It's just trying out. Of course, nothing exists here. So even if a user goes to /sendgrid.dev, they will not see anything, but doesn't stop bots from polling. There's a bot that's trying to hit this again and again. And thankfully I can track that over here. Okay, 8 times this was hit. 1 time it was hit before, and I hit it a few more times right now. So now I have a track of all of these, and given these metrics, I can do so many things with it. I can go to, eventually we will see how you can do this locally on your side as well, but I can go here to my Prometheus UI. If I go back to the slides, what was the architecture like? The architecture stated, you have a Node.js application, you have Prometheus polling it from time to time, and you have a Prometheus UI through which you can get the graphs, the time series data, so on and so forth. So given we have all of this, I can always go to graphs and be like, what is the total number of HTTP requests total over the last 1 hour, or let's say last 1 day. And as you can see, it's, has been going up straight line. Can you guess why it's been going up straight line? Who is hitting our week25.100xdevs.com/ this specific backend? Why is it up in the air? Why is it so constant up in the air? Can you guess? Puzzle question for you. The first day we were testing, the slope is something, but then, Sunday was this live class, after which it's been constantly up. who is hitting this specific service? And the answer is it is Prometheus itself. If you look at it, the slash metrics endpoint has been hit 31248 times. Prometheus is scraping our backend. Every 15 seconds it hits it, which is why there is a constant slope, because slash metrics endpoint is being hit every 15 seconds, and the number of requests are going up. I can actually confirm that by doing route equal to slash metrics. If I search this, you can see it's a totally up in the air line. So the slash metrics endpoint is what is being hit so much. It's not the slash user endpoint. If I do a slash user endpoint, you will see it just got hit once, and then constant, and then once more maybe recently. But slash metrics is being hit constantly, and who is hitting it? Prometheus itself is hitting it. We will see this very soon. We have just done this part right now. We still have to do this part. But just showing up front, this is the power of this endpoint. Given you have this endpoint, you can keep, and this is the power of dimensions. You can filter. If I did not have dimensions, if I had a single HTTP request total, then I would have been able to get the total HTTP requests. I would not have been able to filter based on slash metrics. But since I've added dimensions like these, I can check how many of my requests are failing with the status code of, let's say, whatever, 404. And it's telling, these are all the number of requests that are failing with the status code of 404. How many of them are failing with the status code of 511? Thankfully, none. So that is why dimensions are super helpful. To recap, we have discussed about counters, specifically how do you add counters to your Node.js application. We created a middleware which is being called before every request. And what does the middleware do? It increments the counter with various dimensions. And we also exposed a slash metrics endpoint, which Prometheus will be polling eventually. And here we used client.register.metrics, where client comes from prom client, to return the metrics to the user. This library is what we used here as well. And that is exactly why it has access to the counter. It knows you have created a HTTP total requests counter that is being used over here. Next up, let's understand gauges. Let's understand why do you need a gauge, a use case for it, and how is it different from counters. All right, let's get into gauges next. What was the difference between a gauge and a counter? A gauge can both go up as well as go down. Its value can be decreased as well. A good example or a good use case for this might be the current number of active requests on your HTTP server. If you ever have an HTTP server that a lot of people are hitting, some of them are currently in the middle of the request. They have sent the request and haven't yet gotten the response. A good gauge on your server can be, or your Node.js process can be, how many people are currently in the process of sending a request but haven't yet gotten back the response. In this diagram, that number is 2. Whenever this request succeeds, the user is able to get back the response, the number should go down to 1. If this guy succeeds as well, the number should go down to 0. How can we maintain a gauge like this? I've reverted the code to be fairly simple again, a simple endpoint for slash user and a simple endpoint for slash metrics. What do we need to track now? We need to track the active user requests. How can we do that? Firstly, we need to import a gauge from prom-client. Then we need to initialize the gauge, active user gauge equal to new gauge. We need to give it a name. Let's call it active users, and some help text, which is just some description for this specific gauge. The question is, when should this number go up? When should this number go down? Harkirat, it should be something like this. Active user gauge should increment anytime the control reaches here. Then the request should do its thing. If there is a database call, that should happen. You should respond back to the user, and then you should do a dot decrement. This should be how we increase and decrease the gauge. What is this gauge supposed to do? Anytime a request comes, it should go back. It should go up by 1. It means there is a currently active request. then the request should do its thing. We're doing something very simple over here. But if we had a database call here, or a Redis call here, that might take 1 second, 2 seconds. Whenever that succeeds, we return back to the user, okay, hey, this is the response, and we decrease the value of the gauge. That is one way of doing this. This totally works. You can totally keep doing this and have a gauge that goes up and down on the /user endpoint. But you probably want what? You want a global gauge. Okay, the request could come here, it could come to the /metrics endpoint, it could come to a third endpoint. I want to capture all of these requests. I want the active user gauge to go up if a request comes here, or if it comes here, so on and so forth. So what can we do? We can create a middleware again. And this time, what will this middleware do? It will first increase the gauge. So it will be something like active user gauge.increment. And then it will call next. Along with that, whenever the request finishes is when we can decrement the gauge. That way, anytime a request comes, doesn't matter if it comes to this endpoint or a different one, since this middleware has been attached to all the routes, the gauge will go up, and then next function would make sure that the route proceeds, does its thing. Whenever the response goes back to the user, control would reach this on click handler or on finish handler, and we would decrement the gauge by 1. Let's make this specific request slightly slower. Let's add a delay of 10 seconds to simulate a database call, let's say, or a Redis call that is taking a long time, so that whenever a user hits the /user endpoint, control first reaches here, the gauge increments by 1, next gets called, control reaches here. For the next 10 seconds, the gauge does not decrease. This doesn't get called. After 10 seconds, we return back to the user, control reaches here, and the gauge decrements. That way we can simulate the number of active requests. If I don't add this line of code, what does this line of code do? This is a common way to await for like 10 seconds. 10,000 over here means 10 into 1000. That's 10,000 milliseconds. That is 10,000 milliseconds, which is equivalent to 10 seconds. This line of code waits for 10 seconds before control reaches here. And hence, now we have simulated the /user endpoint to be an expensive endpoint. It takes 10 seconds before the user gets back any response. In these 10 seconds, we want the gauge to go up by 1. And of course, whenever this responds back, we want the gauge to go back down by 1. If I compile this code and run it, and if I go to localhost :3000/user, you will notice the request remains hung for 10 seconds. So wait for a little bit more. And then you finally get back the response. Let's go to the metrics and see. It says active user is 1. Which is this one active request? It is the request to the /metrics endpoint itself. So this is not any user on the /user endpoint. This is the currently active request that you have sent over here. So it will always remain 1 whenever you're trying to scrape the /metrics endpoint. That is you or your active request over here. And then if someone hits a user endpoint, let's say there is an active user now, as you can see, it's loading over here. It means the user is currently in the middle of getting a request. This gauge goes up to 2. After this succeeds, this gauge goes back down to 1. So now we have created another metric that goes up also, that goes down also. When does it go up? When there is an active request. There is an active request here, and let's say here, and let's say here. In 3 tabs, I have active requests. So the active user goes up to 2 only. All right, you learned something new today, which is just how weird browsers behave sometimes. Right now, I have just one active request over here in this specific browser. If I go to the metrics endpoint, anytime I refresh the metrics endpoint, it says active user 1. What is this active user? It is this request itself. The request that you're sending to /metrics is increasing the gauge by 1, and that is what you see over here. As I keep visiting this, you will see active user remains 1. Who is this active user? It is this request right here. But if I go to /user in two different tabs, you will notice it only goes up by 1. Ideally, it should go up by 2. There is one user that's here, and then there's another user request that's here. But the browser prevents the second request from going out. The second request doesn't even go out to the backend until you have another tab which is trying to visit the same endpoint. So our browser is acting a little weird over here. The browser doesn't even send the second request until the first one succeeds. Now that the first one has succeeded, the browser sent the second request, and now after 10 seconds, this would succeed as well. That is why this number only goes up to 2, even though it should go up to 3, because you have 2 new active users other than the main active user. So if I go to /metrics again, it is down to 1. But now let's run another experiment. Let's go to the /user endpoint once from Chrome and once from Brave. So now this number should go up to 3, and it does, because Chrome does send out one request. Brave also does send out the other request, and hence this active user goes up to 3. If I open Postman and try to send another request from here, let's say to the same endpoint, let me refresh this. This is at 1, and then go here, and then Postman will send the third request. Now if I refresh metrics, it goes up by 5 because I refreshed this as well by mistake, but you get the idea. If you send a bunch of requests in the browser, unfortunately, the browser doesn't send the next one until this one has succeeded. But if you send it from different clients, it works. This is just, a weird edge case that we have hit. Our logic is perfect though. Our logic, which, increases the gauge by 1 anytime you hit an endpoint, is working correctly. We were just not able to test it correctly, because if you send a request to /user multiple times in the same browser, until this one has succeeded, the browser itself doesn't send out the second request. This has succeeded. Now the browser is sending out this request. When this will succeed, then the browser will send out this request, so on and so forth. That is why the gauge isn't going up at the pace as it should. Even though there are 1, 2, 3, 4, 5, 6 active requests, let's say, the number only says 4 because the browser is preventing some of these requests from going out. Is our logic correct though? Our logic is perfect. Okay, anytime a request comes, how did I debug this? I put like an increase and a decrease there, and I realized control never reaches here if you open, multiple tabs in the same browser. What does the logic do again? To quickly revise, the logic introduces a new middleware, which first increases this gauge, and when the request succeeds, whenever the response finishes, it decreases this gauge. There is still some problem here. This is not the best way to figure out if a response has been finished. A lot of times this callback doesn't get called because the request hasn't finished. The user just canceled the request. You should probably be listening on, close is probably a better thing to look at rather than finish. Or, if the user cancels the request, in that case also you should decrease the gauge. Either way, hopefully you get the idea. Okay, a gauge is nothing but a counter whose value can increase and the value can decrease as well. Now we're done with the first 2 important metrics. If I go back to the slides, we're done with counters and we're done with gauges. If you go through all the slides, we create like a very full stack application in which, we structure things much better. We have both a counter and a gauge in the same place. I've just explained it in a slightly more toned down, easy to understand. We've done counters separately, we've done gauges separately, but if you go through the slides, you will notice, basically by the end of it, you're able to create code that looks like this, which has multiple middlewares defined, an active request middleware, which, looks something like a single middleware, which increases the gauge also, which decreases the gauge also when the request goes out. It increases the counter also, and it also does one more thing that we'll be discussing next. But if you want to go through, all of this done together in the same repository, the code of that is here in week 26 Prometheus. Specifically, this is the file you want to look at. This is the middleware that we use in index.ts, which does what? It first increases the gauge, and then whenever a request succeeds, it decreases the gauge. Whenever the request succeeds, it also increases the counter. It also does one more thing, which we'll eventually get to. But other than that, if you want to do both the things together, this is how you write the code for it. If you go to source/index.ts, you will see this metrics middleware is what we register over here. With that, let's move to histograms, the third type of metric that is very popularly used and also is very confusing to understand. So let's understand histograms next.